Okay, in this lesson we're finishing up looking at solving open sentences involving absolute value. So in 6.5a we looked at absolute value equations. In this one we're going to look at absolute value inequalities. How is absolute value used in election polls? Voters in Hamilton will vote on a new tax levy in the next election. A poll conducted before the election found that 47% of voters surveyed were for the tax levy, 45% were against the levy, and 8% were undecided. The poll has a 3-point margin of error. The margin of error means that the result may be 3 percentage points higher or lower. So the number of people in favor of the tax levy may be as high as 50% or as low as 44%. This can be written as an inequality using absolute value. X minus 47, that's our center, is less than or equal to 3. So the difference between the actual number and 47 is within 3 points. If we consider the inequality absolute value of x is less than n, if we put in a 5 for n, it means the absolute value of x is less than 5. So the distance from 0 to x is less than 5 units. So it could be 4, it could be 2. Therefore, x is greater than -5 and x is less than 5. So the solution set that could be read x is between -5 and 5. So when solving inequalities in the form absolute value of x is less than n, we're going to find the intersection of these two cases. Case 1, the value inside the absolute value symbols is less than the positive value of n. Case 2, the value inside the absolute value symbols is greater than the negative value of n. So when they ask us to solve the absolute value of s minus 3 is less than or equal to 12, then graph the solution set. We're going to use our case 1, case 2 strategy. So case 1, we just drop off the absolute value. So we're assuming the stuff inside there was positive. Or case 2, we're going to take the left times -1. And so we remember when we multiply by a negative, we have to reverse our inequality symbol. So that's assuming that the stuff inside the absolute value was negative. To solve, all we have to do is add 3 to both sides in both inequalities. So I have s is less than or equal to 15, and this is a less than, so it's going to be and, add 3 to both sides. S is greater than or equal to -9. So when we graph the intersection, I'm going to make my lazy graph here, it's greater than or equal to -9 and less than or equal to positive 15. So that's our betweenness looking deal. So we could write that it's not literally between because we have that or equals to bit, but basically s is between -9 and 15. But it's not quite between because the boundaries are included. Here's a little tip from your book that we just talked about. When absolute value is on the left and the inequality symbol is less than or equal to, the compound sentence uses and. Just looked at less than, so now we need to look at greater than. So if we look at the inequality absolute value of x is greater than n, or a special case we've been looking at is if n is 5, means that the distance from 0 to x is more than 5 units. So our not graphed area would be 5 units on either side of the center, and everything else is going to be graphed. So either x is less than -5 or x is greater than 5. So the solution set can only be written x is less than -5 or x is greater than 5. Once again, when we go to solve, we're going to use our case 1, case 2. So case 1, we're going to assume the value inside the absolute value symbols was positive, so we just drop off the absolute value. In case 2, we're going to look at the possibility that it could have been negative. So if we are solving a greater than, we're still going to use our case 1, case 2. So case 1, we're just going to assume that our number inside the absolute value was positive. So we just drop off the absolute value. And case 2, what if it were negative? So 3y minus 3 would be less than -9 because we have to reverse that inequality. So to solve, we're going to add 3 to both sides and divide by 3. And add 3 to both sides and divide by 3. So just like less than, happened with was that arrows going together. Greater than is going to be an or because our arrows have to go out. So let's see our graphs. Y is less than -2, or y is greater than 4. So there's no cool little summary thing other than just rewriting what we just had. Y is greater than 4, or y is less than -2. And there's our graph. So here's another summary for absolute value equations and inequalities. If the absolute value of x equals a number, then x equals either the positive or negative of that number. If absolute value of x is less than a number, then x is less than that number and greater than its opposite. If x is greater than a number, then x is greater than a number or less than its opposite. And these properties are also true when the less than or greater than is replaced with a less than or equal to or greater than or equal to.